Okay, that oops. Okay, so hopefully now you can hear me, and I'll talk close to the computer. So the phenomena that now we need to move back to the not to this, but to sorry. Now it should work. Yes, good. So what I'm going to talk about is a phenomenon that once you start getting into crowdsourcing or into citizen science, you'll come across it at some point. Either you notice it explicitly or implicitly. It's something that got a lot of name. A lot of time people refer to zip law. I'll explain to you what is this zip law and where it came from. I came across it under the name 1991, and I explain where that came from, and the name that I really like to use a lot of time, the most accessible, is participation inequality, because it kind of captures a lot of things. And I'll explain what it is. And then I'll kind of talk about how participation inequality works in citizen science and scientific crowdsourcing, and why we should be interested and ask where it is. And you'll see a lot of examples of that. And then, why does it happen? Like, why do we end up with that? And and there is some suspicion that it's a law of nature, but still, citizen science and crowdsourcing are socio-technical phenomena. Those are things that humans create, and shouldn't always be just because that's the way things are. So what it is, and then to ask, okay, so if it's happened, why should we care about it? That will be the next question about, do we need to be concerned? And that's the implication. And then, can we do something about it? Oops, if allow you that we need to be concerned. Okay, so this is where the name comes from. So it's after a linguist called George Zipf, who wasn't actually the first person who found it. He found this kind of phenomena that I'll explain to you in a second in the 1930s, and there were people going all the way back to the end of the 19th century that actually started to notice it. So what Zipf have done, he basically took all the words that exist in different books and started counting how many times a word is appearing in the book. And every time a word is appearing, and even we're talking about a or the or we or other words like that, he just kind of organized them in the order of their appearance. And then you count how many times they appear. And what is surprising is that they really match what's called the log-log graph. So they really sit very well in that, and the way to describe it is when a list of measure value is sorted in decreasing order, the value of the nth entry is often approximately inversely proportional to n. Okay, so you get this kind of phenomena, and you'll see a lot of these graphs today. And what is interesting is that it was found all over the place in lots of other things, so not just in books. The most recent paper that I came across that talks about zip law actually talk about, you take as many equations of in physics and a whole book of equations in physics, and you pass it through processing of the different symbols, and you discover, of course, that X is the things that appear most of the time, and when you put all the signs and everything else, it's actually behaved like a zip flow. So things like zip flow also appear, as I said, in many other systems, such as the Tour de France. Okay, so you put in the kind of number of people, the number of winners of each place, and you get something like these things. And it's called a power law. That's another name that you'll find it many times being mentioned. And when you look at social systems, that's actually where I came the first time across it. So I knew about it in the form of Zipflow when you're talking about cities. So cities behave this way. So if you take the population of Paris, Toulouse, Marseille, other cities, kind of, and put them in order of the size of them, the size will behave in the same kind of shape. And there is all kind of literature about it. But what happened in social media? So in general, you can think about the situation in social media where you can look at everyone else, which a lot of times you can't look in the usual situation. So in any social media that you participate in, there are actually a lot of people who don't contribute at all, but are registered on the system. And they are important because they are the ones who's reading everyone else. Okay? So we can call them lurkers. They are just lurking in the background. That's what Jacob Nielsen called them in 2006 when he wrote about it. Then what you'll have about 9% of people who will respond from time to time. So, and most of them once only. And then actually you'll have 1% who are contributing very heavily. Now, if you want to do an experiment, take the office mailing list, the general kind of MPI mailing list, and count who is sending messages there. And do this calculation, because that, and you'll discover this kind of behavior of this Zipflow. And the reason that you'll find it there is because the way that Nielsen has found it is also from work that was done in Bell Labs in the very, very early 90s, looking at the behavior of mailing lists and finding this phenomena there. But what is interesting is that actually it behaves in a much more extreme way as the system grows. So if you look already in 2006, there were people that are doing blogs, and kind of the blogs first started appearing. And when you look at the numbers there, you actually realize that 95%, it's not 90%, it's 95% that are lurkers, 5% that will pass comments or something like that, and 0.1% that are contributing everything. Or if you look at Wikipedia behavior, then what you have is 99.8% lurkers, all of us, all the time reading, 0.2 occasional contributors, and 0.0003 that are actually creating all the information that you see in Wikipedia. And then over the years, this gone worse in terms of the proportion. So nowadays with Wikipedia, it's actually 99.99 lurkers. Again, all of us were just reading the information, maybe 0.0001. So anyone in the room ever click on edit in Wikipedia? Yeah? Well done. That's really an outlier group. But then you have the kind of people who actually done a page. I've done. By the way, I've done the page on Sherry Auenstein, who is the person who wrote the participation letter. So that's what. But when I was studying OpenStreetMap, which is a Wikipedia of maps, and people are creating maps by themselves, I was looking at it in 2008, 2009, and you look at the number of people that contributed at the time, just in England. There were already, the project started in 2004, the country was quite well covered by different people. And what was surprising is that although they already had several thousand contributors, by the time you go over the first sort of 50 contributors, you're already getting into 80% of all the data. So in social media or in crowdsourcing project like this, actually a tiny group of participants are creating most of the data that you're using. And this phenomena continues. So several years later, someone has done analysis on the behavior of OpenStreetMap. Harry Wood is the name of the person from OpenStreetMap who looked at all the data and look at the way that people participate, and it's gone worse. So if you look at the whole phenomena across the whole world, but although at the time there were already 2 million contributors of OpenStreetMap, by the time you pass the 25,000 mark, you actually got most of the data. Again, all these people are really important in encouraging other people, for making them to feel that someone else is doing the work, checking on them, all kind of other aspects. But it is a really tiny group of people that are shaping the whole phenomenon. Okay, so that's kind of the 99-1 rule, and it appearing in a project after project. So this is now an example from a nature observation. So iSpot was a project where people were collecting different observations from nature, like another project called iNaturalist that is doing the same thing, and then other people helping them in identifying what is the things that they have seen. So giving the scientific name of the species that they looked at. And lo and behold, both in the data collection and in the identification, you get, again, participation inequality and a very skewed participation. Now, here it's starting to be serious about what you see on nature, because what the very top are interested in is what the system is collecting. So if the top are interested in birds, the whole system telling you things about birds, but doesn't tell you about butterflies, things like that. So within ecology and all the rest of it, there is talk about charismatic species and so on, but because you have participation inequality, you'll have also skewness in the way that people identify the different species. So, for example, the people that are identifying species over there, also they will identify in different cases, but there is someone who is expert in a very specific area. And of course, they develop huge expertise of analyzing the images. And that's, by the way, my argument about one of the reasons why citizen science data is of such high quality. Okay? Because actually, in most of the data, you have very high expertise in analyzing information and classifying it in different ways. And the surprising thing is that even in the study of things that happen outdoor, not online, just the social, that's actually activity of community, you still find this same phenomena, this participation inequality. So the Conservation Volunteers is an organization where people go and deal with the local parks and taking care after it and all the rest of it. And you look at the number of people that participated in different activity, and what you discover is that most people participate only in one session, never come back again, and there is really small group of people that have participated in more than 50 sessions. So those are the people that come every week, because the session is about every week. Now, if you'll think about those type of activity, if you ever participated in them, you'll figure out that those people that are coming regularly, really important to keep the things going. Everyone knows that, Arnold, who is always coming, and without him you can't start, and because of him he's also taking care of the new people that just come across. But at the same time, you really need the high numbers in order to eventually get to this large crowd of people. And that's one of the principles of crowdsourcing, that you open up to a very large population. And actually, in a lot of crowdsourcing projects, what it turned out to be is that you do this huge thing, not just to get people and recruit them, but to create the pathway into those very high contributors. Okay, so it's there, okay? I think that I managed to convince you that wherever you look at the project, citizen science project, you're very, very likely to find this thing, and it's happening across the board. So why does it happen? Why do we get a very small group of people that are contributing huge amount, and a lot of people that are contributing almost nothing. So one reason, for example, is that the project includes some finite resource. Like in the sense that if we look at something like OpenStreetMap, the moment that I map a street, nobody else can map the street because it's already there. They can correct me, but I've done the whole work. So if we're counting in meters of who maps more area, then when I've done it, nobody else has done. And you can actually see it in, this is analysis of central London, so you don't see it, but it's small numbers that of different locations, so how many people participate in mapping each square kilometer. Now, the moment those people finish mapping the square kilometer, you run out of opportunities for other people, and that will create this type of inequality. Another thing that is related to it and also connected to it is the barrier to entry. So OpenStreetMap, for a long time, it's improved a little bit, but it's still the case for many, and it's true, very much true of Wikipedia, is actually creating a barrier to entry. Okay? Anyone here who updated the Wikipedia page know that the editor is just horrible. Okay? It doesn't fill you with confidence about editing it. And that's something that a lot of time also create a barrier, and a lot of time people will prefer to be lurkers because it's more difficult to become a contributor. And in Citizen Science Project, we do have cases about people being afraid of contributing to the project. So we see them even registering on an online citizen science project, but don't contribute anything because they started doing a task and then decided, actually, I don't have the expertise to do it properly. This is a scientific project. I don't want to spoil it to the scientists, so I avoid it. And they feel a lot of responsibility over their data and just don't want to go ahead and contribute more. That's something that you can solve with design, for example, of telling them that other people will also look at the same data, but let's leave that aside. But if I said that there is a finite resource, what do we do? Like, why does it happen in cases where the resource is not finite? So for example, if I watch a bird, that doesn't stop you from watching a bird, and it doesn't stop someone else from watching a bird. Okay. So what's going on with the in cases like that? There are actually some factors that play out in these cases. So this is the map of observation from eBird, which is an international project of observing birds. And if you look, you actually have emptiness in a lot of areas of Africa. You see areas in India and in China that are missing and so on. So what's going on? In these cases, there is actually participation does require resources. So for example, to be a high contributing observer of birds, you do need to go around and have the resources to have free time and to have the binocular and camera and to be able to travel across the world. And there are some examples of people traveling 1,500 miles and even more in order to watch a specific bird. So that's another kind of limited resource reason to do that. There is also technical things that stops you from participating. So for example, again, Zooniverse, the first million participants that contributed to it, you see very much Europe, United States, you see less India, but some bits of it, and you can't see other bits of the world. No access to the internet, no ability to participate. So that, you can say also infrastructure is playing its part in that. But That's kind of say that there are some reasons and there can be other hypotheses about why it's happening. I'm not trying to be exhaustive about the hypothesis, but we can think about how the mechanism happened. And why it is interesting about the mechanism, it is interesting because in all this project, they started from an equal footing. So when Wikipedia started, there wasn't any page. Anyone could join in and start contributing. In eBirds, when you join in to a specific area, nothing stops you from collecting as many observations as you want. In iSpot that I showed you, again, people can contribute as much or as little as they want. So why do we end up with those skewed distribution is an interesting question. So the next question that we need to ask is, should we care? Like, is it really important? So here's an example from Google Maps, which, you know, a lot of people are using. Actually, 1.5 billion people around the world, at least, are using it in different way. And you look for, say, restaurants in a specific area, and it will select, say, for you, the restaurant with specific number of stars that people want to. Guidance on how to do. The only problem is that within Google Maps, when you study the Google Local Guide system, you realize that what's happening is that there are 1.5 billion users, of which Google is saying that 150 million contribute something. Now, we know from everything else that most of them contributed once and never again. One image, one review, something like that. Once you look into the higher contributors, those that belong to the program called the Google Local Guide Connect and other things like that, you start seeing that there are something around 500,000 of these people, and at the higher level 8, 9, 10, where people are contributing huge amount, the numbers are, of course, much smaller. And that tells you that the ratio is actually 90-10-005. Now, this 0.005% are influencing everything you see. They are in control of the businesses, the restaurant that will be successful or not successful, because they have specific characteristics of what we are seeing around, you know, the kind of things that we've just talked about. Those will be people that are usually more affluent, will have more free time, and all kind of other characteristics. Then they will have huge influence over the rest of the system.
Is there an estimation of how many of these are actual people? So bots, fake profiles?
Yeah, there are people, because Google actually check for location and visit. So they check that you visit the place, and that's based on the phone. So they have Google Local Guide is relatively safer. Maybe in the comments and other things they are less, but generally speaking, the system is quite based on people. You know, you need to be in a place in order to take a picture of. So what are the impacts of this aspect? So that's just one aspect, but you have different aspects of it. For example, you get a spatial bias, the coverage of where those very small group, very highly contributing group will influence what kind of information you will see, and you'll get much more information from where they are compared to other people. Now, because it's a scale-free phenomena, you will have a lot of local people, and that's kind of interesting. If someone is very motivated to be the top person in the area, there can be a lot of top people in the area. We can actually think about that in a certain way. There is also a temporal bias. When those people are available, what they are doing, which days, week, and seasons they are operating, what is their free time, and so on. There is the attention aspects of which species are being observed or which information is being collected, and personal biases and interests will influence, again, the whole system. There is the benefit from participation. So you can get benefit by learning. Apart from the fact that other people are using your data, you can actually learn about the process of involving in science, and we can think about this participation, how it influences who enjoyed the benefit. Then there is also the issue of the knowledge that we are getting. So I mentioned to you about specific species, but also it's about the places people are visiting, the area that they are recording, the information they're collecting, and especially nowadays when we're using this information in order to activate AI systems, we need to think, what kind of world are we representing to the AI system based on this information? So a good example is Wikipedia. Without pushing Wikipedia to represent many more women scientists, then the AI that will based on Wikipedia without it will conclude out of the information that scientist is a man. And that won't be biased in terms of the data set that it's getting, but in terms of the world, it will be biased. So, and there is political and decision-making implication of citizen social science activity, collective intelligence, and other things like that can influence also the aspects. And here's an example of it from a project in Brussels. So this is a Curious Nose project where people were having diffusion tubes and they were putting them out of their home and covering the whole area. So now you see what looks like good coverage of Brussels. Apart, if you look carefully, this is Molenbeek, which is the poorer neighborhood. And if you look carefully, you do notice that it's less covered than other places. And that's something that was used in order to change, say, the policies of air quality and car management in Brussels. So if you're doing, say, a campaign in citizen science, and you don't take account the skewness, and then put an effort to go to Molenbeek and convince people to put in the diffusion tubes, not only you get the data wrong, you'll also influence the policies that will be made on the basis of the data. Can we do something about it? Okay, so now I explained to you what it is, I explained to you why it's coming, I said what it might be, and then what we can do about it. So Jacob Nielsen, in the original paper, in the original article from 2006, was very pessimistic. He said, if you are, and he wrote for people who are doing human-computer interaction and usability studies, and he just said, can you overcome? No, you can't. Okay, that's one approach. But there is something in it, and if we'll take the natural phenomena side of it, which absolutely it's there, it really is wrong. Zip didn't found nothing, and once you start looking at it, you start realizing that participation inequality is all over the place, from political participation to sport to everything else. Okay, so just kind of start thinking about, say, tennis, and you figure out that you have huge amount of people who never played tennis ever, then a whole group that played tennis once and never done it before, then all the way to the people who play tennis as amateur, doing it once a week, but will never end up in the Roland Garros, and finally, you know, the top league of what it is, and actually you get this participation inequality. So once you start looking at it, you see it everywhere. But to be that pessimistic and say that it's just there and you can't do anything about it, I'm not convinced about it. Okay, so I think that under certain conditions, we can get different participation. Example, we can force people to participate in different ways, and we can work on the way that they participate. So we can tell them, for example, in election, not go and elect again and again and again. You are allowed to elect only once. Okay? And that's a way to do that. And if we're Australian, we force them to go to the election booth, and then we get as many people as possible. So there are all things to do with it. It is a social technical system, and therefore you can do that. But the first thing that it's obvious is that if you're involved in anything that include crowdsourcing, you should check for it. You should assume that it will happen and either design for it or design against it or something about it as you go along. And then you should check for expected bias and maybe move between different places. So I, for my experience, differentiate between passive inclusion, which means I've created a website that is accessible for all, and whoever wants to come along and help me with this project, which is how we end with it, to an assertive inclusion, where I'm actually thinking, who do I really want to participate in this thing? And I'm not investing a lot of effort with educated people with a lot of knowledge who will come anyway, because I know it from all the other participation curves, and I'm using my resources to go after people who otherwise won't participate. Maybe that's one way to deal with that. But I don't have a perfect answer, of course, for this thing. So here's the summary. It's a natural phenomenon. You see it everywhere, and it appears across human and natural system. It's something there, and it's an interesting phenomenon by itself. But there are plenty of questions on the dynamic development of it. So how it developed. Let's take something like an event where you tell people to collect data. There is something called City Nature Challenge, which Zara, one of the PhD students here, is exploring. On the first day, there is no one collecting no data. And by the end of 3 days, you get the participation inequality. Something happened there in the dynamics, either with the leaderboard or without the leaderboard. What happened in different situations is something that we can ask questions about, and maybe there are answers also in the work that Mark is doing with Joggle and with other resources where we can look from a starting point of zero until it develops and what's the dynamic of it. So there are a lot of questions about that. And we need to consider the mechanism also for possible intervention, if you want to intervene and if it's possible to intervene. It's really interesting if it's possible to do it in any way, and then to think, okay, so which intervention? And with that question, I'll kind of open up to questions. Thank you.
Questions in the room? Maybe to comment on that last part, as indeed, sometimes you can have a fractal setting, like we see in some communities where some leaders are local leaders and they will be seen to impact less on the curve. But if you like zooming in, they are locally contributing a lot to the local group. It can be a result of kind of fractal organization.
Yeah.
Sometimes so it's not necessarily that's a capture of flow. Then what's interesting to look at is the dynamics of whether you cycle at 1% in time or whether there is a turnover. So for me, the question becomes more like, is it a steady state distribution where, is it captured and growing?
Yeah.
And that's what kind of distinguishes it healthy from an settings.
Yeah, and one study several years ago was demonstrating that among the very competitive people, once someone is pulling ahead, the other people are dropping out. And that's, for example, a reason why to be very careful about leaderboards in your project. So if you are creating, and that's an interesting thing that you can see in the way that, say, Duolingo created their gamification, they are actually creating localized leaderboards. So they are sorting the different people who are studying in an intensive way and split them into different leaderboards where you are kind of held in a bucket with people that are similar to you in order to have both the competition but not to lose too much of the energy, because then you will drop out completely from the system in order to do that. So it's possible to do something about it within the case. I'm not sure how well it works in the case of Duolingo because there is a little bit too much trust in Duolingo with algorithm and not human intervention.
Academic labs. Like if you look at citation
Yeah,
numbers,
same.
et cetera, et cetera. I think it might even be higher, right?
Yeah.
Probably 95, like 95, 0.1. I mean, I don't know, but it's like
it's depending on the size.
Most of the innovation, right, judged by different criteria, including citation, probably falls in a small minority, right? We know that by large, most papers are not cited even once.
Yeah.
Right? So
Yeah.
it's long tail distribution and it's completely there.
Yeah, exactly. And if you take academic paper in a specific discipline and you put in the academics according to their citation record, you will get a participation inequality pattern. And again, you can think about mechanisms why it's created. It does create all kind of problems. It also creates the same problems with funding. So I'm actually a beneficiary of the stuff. Yeah, exactly. Exactly. So one way is to avoid track records and other things like
when
that.
you see a leaderboard and you're far behind, you
Yep.
don't do any effort.
Yep, exactly. So those things happen in academic research, and they are just as unhealthy in many ways to system. So that's kind of the balance between the natural phenomena and the human intervention with the system and the degree in which you can do that.
Hello?
Yeah.
And can you tell us a bit more about the profile of those who tend to participate, and if it's possible to identify those criteria in order to work on them?
Mm-hmm. Yeah. So what we know across citizen science project is that it's the highly Other will have high representation of women. They will have either one way or another. There are more male-dominated projects than female-dominated projects, but that's a lot connected to the project and the way that it's represented. And there are highly successful female-led and female-engaged projects. There are even just female-engaged projects that are very successful around. Age, also there are kind of different groups. There are projects that are really successful in older age groups, whereas the projects that are going after, say, youth have the problem that they need to recruit people all the time. So those kind of some of the characteristics. But say Google Local Guide, it's really an interesting one. If you look at Google Local Guides, on the videos, it will show you a whole variety of people of different age, gender, other things. The reality of it is more like me, you know. When you start clicking and looking at who is participating and look at getting into Google Local Guide Connect and look at the profile of the people, again, it's not very surprising that older men will have more resources, more travel around the world, more time and more confidence about taking pictures in restaurants and sharing it. Yeah.
So the waiter needs to be extra nice to the men.
That's a problem. Yeah.
Yes, I'm going to read it. It's from Monica. Do you know any intervention that fosters adolescents' active participation in scientific online forums such as Ask an Expert or discussion groups?
No. That's a very simple way of answering. Yeah.
But what about like I don't know, conflict zones, or we were talking about the war situation where we ask people on sites to collect data and measure a sample of, I don't know, soil or anything.
Yeah.
What about this? Is it different since it's a life matter to collect data?
Yes. So this is really, we can take a little bit less dramatic situation, which is the COVID. So during the COVID, for example, a company in the UK called Zoe started creating an app for people to report about their symptoms. And because of the emergency of that, plus the fact that people have free time and were sitting at home, they started reporting on it, and the app was very well designed. And what was valuable is actually this app identified a symptom of COVID that was not well known before they started it, because people were started reporting that they were losing smell and taste when they are getting COVID. And because in this case, they've grown really rapidly to 4 million users. Now, remember, the 4 million users are not the 90, they are your 10. Okay? So out of the 4 million, they still have the very small percentage, which is likely to be something like 50,000, 100,000, probably more, that reported every day on their situation and symptom, and that's actually provided a really good way of understanding their symptom and improve on it. War situations are just difficult because of the risk for life, but in reconstruction, we're also seeing it a lot with OpenStreetMap. After the Christmas tsunami that happened in 2010, again, there was a lot of attention to it, and you get a lot of response to it. Or after Fukushima, there have been a lot of citizen science around nuclear detection in Japan because of awareness and all the rest of it. So you're absolutely right that it's a very important way of getting people engaged, and some people will continue and participate after it.
More questions?
Okay.
I have one actually.
Yeah.
I'm interested in what you said about designing against this phenomenon. What are some of the ideas? Because you showed that it's easy for the 1% also to game the system, to influence other people. There's this notion of dictatorship of the minority. I don't know if you know this.
Yeah.
That comes to mind. So what are some of the ways to design against this phenomenon?
So even when you go to the Zipflow paper, you see that after you cut in the top one, you continue to get, you don't get, it's not completely scale free. Okay? So the phenomena of Zipflow actually, when you take the books, the even original work that Zip have done, you see that after you cut the top, it's actually a more messy distribution. And one way to do your analysis is actually to do your analysis by knowing that this happened, taking away those people, let them less influence it, then do the analysis with the rest of the data, and then bring them back. Okay? And because that will give you a more representative way of understanding what's going on, and then to think about the phenomena. In some cases, what you want to do, and that actually makes sense to do in things like OpenStreetMap, you give someone amount to do during the day, and then increase the cost of participation or some phenomena in order to ensure that they leave space for other people to do the work. But in other cases, a lot of time we're talking about wisdom of crowd system. So the fact that one person is classifying a lot of galaxies doesn't stop someone else from classifying those galaxies again, and they provide some quality assurance to other people. So actually, it's really will depend on the phenomena and how you want to do it. But on collaborative system, you really need to work out. So one of the fellows that was here, Omri, what's his name, on the Wikipedia? The one from Israel who was doing, Omer, yeah. Yeah, so when you look, for example, you check the community of Wikipedia editors in Israel, actually you get exactly the phenomenon that you described. A small group of people really controlling what is accepted, what is notoriety and importance and all the rest of it. And that's really shaped the whole structure of the Wikipedia in Hebrew to a degree that it's not reflected of any other language community. And to the worst of the community, and Wikimedia Foundation doesn't have the guts or ability or rules to actually rain down on this community.
So it's a real problem.
And that's created a real problem. And the same things for OpenStreetMap. OpenStreetMap started in 97% men, and they just can't shift it. And if you go to the mailing list of the core group, it's toxic. I have no other word to describe it. Like, people are really aggressive toward each other. And part of the story is that they are doing that in order to perpetuate the culture that started 20 years ago. And the surprising thing is some of the people, I know them for 20 years. They are still there. They are still generating the same culture. And it's became a very strong culture that you can't shake out of the system. And that is a problem. Yeah.
Do you have any example of citizen science project that successfully, at least a little bit successfully achieve more representation or?
Yeah, it's a really good question. I need to find examples. Okay, I think that the open air laboratories in the UK, a project called Open Air Laboratories, that was going after schools and engaging schools in the project. If I'm not wrong, they have managed to kind of make sure that all the schools are represented and they're going after the school instead of the school going after them. So because if you would go into the other system, within few years you'll have the more affluent schools who can afford having all the children doing it again and again. And what they've done is that they actually use the resources in order to go deliberately to the poor schools around the country and visit them once. And they knew that it's not necessarily going to repeat itself, but they wanted to cover a lot of school children. So I think that they've managed it, but I'm not sure. Like, it's a really good point. Thank you.
Does it tend to evolve with the situations? It's not.
Yeah.
I mean, it's not maybe in the US anymore, but anywhere else we try to work on inclusion and stuff.
So leave a system on its own, create a crowdsourcing system, empty crowdsourcing system, open it to the world, and don't do anything about it, it will happen.
Okay.
I'm willing, the likelihood of that happening, it's very high. Now, under which condition it won't happen, it's really an interesting question that I would love to model and simulate and actually do research on it, but I just don't know. Yeah.
Just if in order to log in, right, it's only when a woman logs in that you as a man can log in.
Yeah.
Right, and create bottlenecks like this, that you bring a friend woman to join in. I mean, that you have to make.
Yeah, you have to make design this.
You have to make very artificial.
Very design decisions.
Very
Yeah.
artificial
Yeah.
kind of systems, system like this.
Yep.
You have also to have a large sample of participants, because if you have only 100 participants, then there's only one person dominating everybody else.
So not necessarily. So that's why I'm saying that I have the experience. So I've done work with communities, and again, I remember that there were 60 people coming to the first meeting, of which, say, 4 were stepping forward and saying that they want to be citizen scientists and they want to contribute data. And then out of the 4, one of them was really contributing, say, 30 or 40% of the data, leaving 20% to each another. But we work with them collaboratively to make sure that nobody is kind of taking over the other people and so on. But that's kind of, that's why I'm saying that it happened even on a small scale and another scale. But then when they came back in the result, all the 60 people own the data. So when there was a meeting with the local authority, actually those people, the 4 people that I mentioned, they presented their results, but then other members of the community interpreted what they were doing and were using, say, their local memory and history and relationship with the authority and their standing within the community to kind of express their view. It's so in small, like, that's what I'm saying, that it's almost natural phenomena in one side, but also that it can happen in a more collaborative way, where in a social situation, you'll have different people with different life stage, with different standing in the community, and it will play out in different way. Yeah.
This
Okay.
is it. Thank you very much, Muki.
Thank you.